Okay, welcome to the beginning of our trigonometry material. So this is chapter 1, and we're gonna, not too surprisingly, start with section 1. And chapter 1 is about trigonometric functions. I believe they're going to introduce the actual trigonometric functions in 1.3. But before we get there in 1.1, we're going to look at angles. And so our goals for this section are to look at the basic terminology of what angles are and what that means, degree measures, the standard position of angles, coterminal angles, all of these things they're mentioning here. These are our sort of topics and objectives for this section. So let's begin with some basic terminology here. So they begin with talking about a line. Two distinct points determine a line. You may recall this back from some old algebra, that if you had a linear equation or something, if you had 2 points, then you can draw a line through those 2 points. You can also get the equation for the line, et cetera, et cetera. So just in terms of geometry, as soon as you have 2 points, they determine a line. There's only one line that goes through those 2 points. And so we have some labeling to look at here. They say the line AB. So just focus on that, because we are sometimes going to be imagining a line, and you want to think about the line being defined by a couple of points that it passes through, and they have this nice little picture to illustrate that. So because 2 points determine a line, we often use this as the way to label the line from A to B. And when we say from A to B, that doesn't mean it actually starts on A and stops at B. It keeps going in both directions. But if we say the line from A to B, that means the line that passes through those two. If we actually wanted to just talk about the line that began at A and ended at B, then we would call that a line segment. And we would say the line segment from A to B, or line segment AB. And that means that you're just starting and stopping there and not going past that in either direction. And then, of course, the final alternative on the slide here is that you could keep going in one direction, but maybe you started at one point. So a ray is a line that basically starts at a point and goes off in a direction and keeps going, but it didn't go backward behind the point before that. So in this case, the ray AB, as demonstrated here, that's our third version of an AB line, is a ray. It started at point A, went through B, and just kept going. All right, so we want to start with these because we're going to use these to construct angles, and down the road, you're going to kind of try to still be envisioning these kinds of things in real world problems. This looks like a totally abstract math thing, and in a way it is. But when we're forming angles in the real world, we're going to be using these ideas of lines, line segments, or rays in order to help us do that. So these are kind of important. All right, so let's get to the angle. An angle consists of 2 rays in a plane with a common endpoint. So the endpoint they're talking about is this point sort of right here where the lines meet, or where the rays meet. And so if you have 2 rays that started at the same place and went out from there, well, then the angle is this image that you get, and you imagine that it's kind of the opening between the 2 rays here. So it's not just this picture of these 2 arrows stemming out from a point, but what we think about when we think about the angle is kind of how wide apart the rays are spread from each other. That's the part that the angle is referring to. The 2 rays are the sides of the angle because they kind of show you where the limits of that spread go toward. This common endpoint gets the name just so that we can refer to it, called a vertex. But the idea of an angle is the spread apart between the 2 lines. So you can imagine an angle as if I'm looking in one direction, and then I decide I want to look at a different direction, and I have to turn my head to look in a different direction. How far did I have to turn my head? That's what creates an angle. How far apart those 2 directions are from each other in terms of if I start at this point and I had to turn from one to the other. So you can kind of imagine an angle being created by having this bottom line that's laying flat, and then you kind of have to go up toward the top line by some amount, and how far you had to swing up to the top line, that's what the angle refers to, that gap between the 2 rays. let's try this. Do you think you could think of an example in the real world in which an angle would be relevant or be involved in some sort of an example? I recommend, even if you don't want to share it, in your own mind, the way these concepts become meaningful to you so that we can use them, eventually there's going to be real world problems in play, is that you kind of try to think of an example in the real world where this might be in play or might be used. And even if you don't want to share it, if you try to think of that in your mind will be trying to then understand this concept in a very clear way. So go ahead, even if you're not going to share it, try to think of it, use your imagination. And then if somebody's willing to share one, maybe you could provide a specific example where there was an angle involved.
So what came in mind is a clipper. So when you clip it, the vertex is the touching points of, let's say if you are clipping it to a paper, the vertex is on the paper basically. Then the angle spread based on the clippers type.
So you said a clip?
Yep. So I have a clipper here, and there's an angle, and when you clip it on the paper, it closes up as in from
so
your
you
diagram.
Those like big metal, like black
Yep.
paper clips that kind of spreads apart and closes like that, right?
Yep.
Yeah, that's a great example. Anyone else want to share one?
Clocks.
Clocks form angles between the minute hand and the hour hand or something like that, right?
Yeah.
Oh, that sounds like a potential trig problem or something. But that's exactly right. So that's a great example as well. So you'll see angles around you all over the place when you start to look for them. And so I think it's a good starting point so that these things initially just sort of show up theoretically, but pretty quickly you can imagine using that theory in different places to try to resolve issues or solve problems. All right, so let's keep moving. So once we have these angles defined and we imagine how big a spread there is, well, then we talk about how to measure that. So an angle's measured, a measure of an angle is generated by a rotation about the vertex. So that's why I kind of drew that arrow on the previous slide. They're now putting it in here. Some way we want to have a sense of how far did we open up the space or the angle between the two rays. And we'd like to be able to give a value for that. Like you can say how tall someone is, or how long something took to do, or how much something weighs. We want to be able to have an idea of whether an angle is big or small, and which one is bigger and how much bigger, and things like that. We want to have a way to measure it. The ray in its initial position is called the initial side. So the initial side is referring to this part right here, that first ray. The ray in its location after the rotation is the terminal side. So the terminal side is this picture, is the ray that's on top there. And the rotation from the initial side to the terminal side is what's indicated by that arrow in there. And I'll draw another one to illustrate that. So you can imagine an angle being created by an opening being generated as you open up the gap between the two rays. And then when you finally stop somewhere, then you can measure how big a gap was created there, how big an angle was generated there. Now, we haven't talked about like what numbers we use to measure that. You may recall that this is going to be a degree thing, but we'll get to that. So the first thing we want to do is just give what's called an orientation. So a positive angle was when you started rotating the ray in the counterclockwise direction. So again, a clock kind of spins around the way a clock does, where you kind of see the dial, if you're looking at it, moving to the right as it leaves the 12 and going in that direction. That's clockwise. Well, if the clock dial seemed to be going backward, then that would be called counterclockwise. And so actually the backward of a clock, the counterclockwise, is what creates a positive angle. So if I'm looking at the two rays that they're showing in these two pictures here, they look pretty close to each other. They look almost like the same little picture of these two orangish, yellowish lines or rays. But they're showing that if you're considering the opening or the gap between those two always, this is the initial one is here. So here's the initial side. If you're going from the initial side to the terminal side in the counterclockwise direction, that produces a positive angle measurement. That to get an angle measurement in the counterclockwise direction will always produce a positive angle. But you could say, well, it's a lot quicker if I go from the initial side here. And what if I just backed up and went down instead in the clockwise direction? Well, you can do that, but because that's in the opposite direction of what we're going to have as our convention, you're going to get what we refer to as a negative angle. And you can imagine if you were like turning and counting, if I'm looking in a particular direction and I start to turn to the right, I can say I'm going 1, 2, 3, 4 spaces to the right, or 4 degrees or 4 measurements to the right. Well, what if I go to the left? Well, if I'm going 1, 2, 3 to the right, then I say to the left, I'm going to call that -1, -2, -3. So that means that if you're going in the clockwise direction from the initial side, that's when you get a negative angle. And if you go the direction that's initially suggested as the default, if you go in the counterclockwise direction, that would be the positive angle. All right, so we still have yet to discuss how do I put a number on that measurement. We're just talking about whether the number would be positive or negative, and that depends on the direction in which you measured the opening that was created, counterclockwise for positive, clockwise for negative. So now let's get to the actual units of the measurement. So when you measure anything, there's often a possibility that you have different units of measure. Like if you're going to measure distance, you might use feet or yards or miles or centimeters or meters or kilometers. So there's often different units of measurement, and the same will be true for measuring an angle. So the kind of unit we're going to focus on initially, the most common unit for measuring angles is this degree. This will not be the only measurement we use for angles, even in this class. We will use others quite regularly. And actually, math often does not use degrees. It uses something we're going to learn about a little later called radians. So I'm just going to put that here so right away you understand, even though we're looking at degrees, that's not the only way to do it. So I'm going to put here that radians comes later.
Professor, I had a quick question.
Yeah, go ahead.
In the previous slide, you named the angles, or like the initial side in it. What does that mean?
Oh, I just meant that short for initial.
Oh, initial, thank you.
All right, I got too lazy. I appreciate your helping me keep clear. Yeah, I always appreciate if I look something like, what is he doing there? Just ask, and I just probably could do better and elaborate a little bit. Thank you so much. All right, so yes, degree measurements is most common, and so that's a good thing to start with. So the way they help us understand how to measure with degrees is by having a complete rotation where you started on your initial ray, and then you started rotating and you went all the way around until you ended right back up where you started. So in this case, we're not seeing 2 rays here because the initial ray came all the way around and landed right back on top of itself. So the terminal ray and the initial ray are now kind of overlapping each other. But the purple arrow is supposed to show us that they did rotate all the way around to make that happen. And so one complete counterclockwise rotation all the way back to where you started produces a measure of 360 degrees. And that's kind of like saying, here's how big 1 meter is. You have to have sort of a starting point of something that everybody agrees on. And so we're agreeing that 360 degrees is once all the way around. And then we can always do smaller portions of that. So for example, if all the way around is 360 degrees, well, what if as I was going around here, I stopped halfway around? So what if my terminal side was pointing in the opposite direction of the initial ray? Well, then that angle just from here to here would be 1/2 of all the way around. So I could take the 360 degrees and divide that in two and realize that that would then be an
180.
angle of 180 degrees. Is that a question there?
Oh, no, sorry. I didn't realize I unmute myself when I was
No
saying
worries.
180 at the same time.
Perfect. We're simpatico. We're thinking of the same thing. Or similarly, I could go 1/4 of the way round, and then 1/4 of the way, which I'm now going to get sloppy on my drawing here, would be 90 degrees. And you've probably heard of before 90-degree angles being important because that shows up in algebra for the corner of a right angle. They call it a 90-degree angle. And you can see that if you went 1/4 of all the way around, then the two rays kind of form the corner of a rectangle or a square or something like that. They have this right angle, or as you've seen before, a right triangle. And so 90 degrees is a very, very common angle that we see, and it's used in construction and in right triangles and things like that. But you could have a 1-degree angle, would just be a little teeny bit of counterclockwise rotation. You could go all the way up to 90, and then you have kind of perpendicular was the term used in algebra for two lines that meet at a right angle like that. Or you could go halfway around the circle and have 180 degrees. You could even go further like they did over here. So now with that in mind, we could try to pretend that we could estimate what these degree measurements were. I don't expect this to be right, but here's a way to see if we understand these degree measurements and try to apply them. What would be a guess for the positive angle on this left diagram here? We know we didn't go all the way around, so it would have to be less than 360. We know we went well over halfway around, so it would have to be more than 180. What do you think?
290 maybe?
290?
290 or like 270 maybe. Actually 280, never mind. Why am I saying it's 270?
Well, those are all possible angle measurements. So for example, we know here we're at 180. And if I go another 1/4 of a turn, that would add another 90, right? So this is 180. And this is 90. And if I add another 90 degrees of opening, 180 goes to 270. So which of these looks more likely if 270 is pointing straight down there? The 280, the 290, what do you think? Maybe 290, something like that. Could be 300, something like that. But getting a feeling by trying to take a guess that doesn't have to be right, but kind of ballparking the value, that's when you get a sense of what an angle is. And so what would our negative angle be measured over here on the right? Just as a guess.
Maybe 45 degrees.
45, so here's a right angle. That would be negative 90. And so if I'm split directly in the middle between of my right angle, I'm thinking that's about there. What do you think? Is that kind of halfway between the two rays? Something like that. So because the two rays going down and to the right would be where the negative 90 is, then halfway between those would be 45. So I'm thinking it's 45 is pretty close, but I'm thinking it's clearly more than 45. So I'd be guessing more like 55. What do you guys think?
Sounds about
And
right.
I need to put a minus on that because it's 55 in the negative direction. What do you guys think?
I would agree.
Yeah, I'd probably put it at
Yeah, it's cool.
55.
That's cool.
And does this concept make sense? Are we feeling okay about this, or should we explore this some more before we move on?
I've gotten it down.
So I kind of like this 1 over 360 is a rotational amount that gives you 1 degree. So 1 degree is small. If you imagine trying to envision 1 degree, the two rays are pretty darn close to each other, right? They're not really separated much at all when you're down to 1 degree. So that's why you usually have 90 degrees or 50 degrees or 30 degrees or something like that. All right, well, they're going to give us some now and give a sense of these range of values. And each of these ranges of values also gets possibly some new vocabulary, some new words, just so we can refer to the size of an angle, even though if we're not exactly sure, we can say, oh, well, it's an acute angle, for example. So what does an acute angle mean? That it's between 0 and 90 degrees. And then, of course, as I was just mentioning, a right angle, which goes back to right triangles and things, is when you're actually at 90 degrees. And then when you go past 90 degrees, you get to an obtuse angle. And if you go all the way to the halfway point, it's a straight angle because you just got a straight line when you add those two rays together. Now notice they don't really say anything about a positive angle that's bigger than that, because you could then use those words to describe the negative part of an angle if you went further than a straight angle when you were going around. Now, what's going to be very commonly used in this class? An acute angle. So it's best to begin getting very comfortable as you can with degree angle measurements everywhere from 0 up to 90 degrees. So these are just words that we'll slowly, hopefully get accustomed to as we use them. Vocabulary issues aren't really crucial for this class, other than being able to do what you're supposed to do when we get to the problems. But in the beginning, they may actually just ask you direct questions where they're saying, you know, is this angle acute, right, obtuse, what is it? And you have to use, you have to choose the correct term. All right, so now we're going to introduce some more vocabulary. We have complement and supplement. And it says, as in this example, find an angle measuring for an angle that's measuring 40 degrees, find the measure of its complement and its supplement. So they're just telling you how to do it, and that's their way of defining the words, which seems kind of simple, but also silly to me. So to find the measure of its complement, subtract the measure of the angle from 90. Why is that? Well, because here's where the slides are feeling a little funny, because in the book, they kind of say what a complement is before they ask you to do this. Two angles are complements of each other if they add up to 90 degrees. So here's the idea behind that. If I take a 90-degree angle, which is this right angle, and I stick a line to split that into more than one angle like this, I introduce a new ray and I just kind of cut it down the middle of this right angle, then I get two smaller angles here and here. And this word complement is those two angles. So basically two angles are complements if you put them next to each other and they add up to a right angle. And anytime you take a right angle and split it into, the two angles that you get are complements. So it could be 80-10, 70-20, any two angle numbers that add up to 90. That's the idea of a complement. So if you know that a 40-degree angle is one of two angles and the other one is the complement of the 40, that means you know they add up to 90. And if they add up to 90, then you can find out the value of the other one by subtracting the 40 from the 90. And that's why they're telling you what they're telling you to do in part A here. To find the measure of its complement, since they add up to 90, you would say, I have 90 as a total. I subtract 40 from the one that I'm given, and then what's left over must be the other one, and that's how they get 50 degrees. Questions, comments, discussions about that at all? So then what is supplement? What's this other word? They're still doing the 40-degree angle. Find the measure of its supplement. It says to subtract from 180. Well, that means that the two angles added up to 180. Going back up here, if I have a straight line and I introduce a ray on a straight line to split that big 180-degree angle into two parts, well, then we call those two parts supplements. And we call those two angles supplemental angles. And one is the supplement of the other. And so that means they add up to 180. So if I know one is 40 and the other one's the supplement, then I would say 180 minus the 40 will tell me how much the other one is.
40.
And that's why they're telling you to do the subtraction here. And then you'd get that the other one must be 140 degrees.
Mhm.
Questions about that? Are we satisfied with that description, hopefully? Well, now they're going to rely a little bit on some of your algebra from the past. So here they're going to say, so for an example, once we know these, we can use this relationship and this definition and do some problems. Find the measure of each marked angle. So what we're supposed to do from this diagram and all the definitions that we've just discussed is realize that the total of the two angles put together forms a right angle. So therefore the total is 90 degrees. And therefore we know that the angle measurement down here, which is 3x, added to the angle measurement over there, which is 6x, meaning we don't know what it is really, but because there's an x involved, that would have to add up to 90. So because of that, they're using the terminology, they're complementary. So then that means that 6x degrees plus 3x degrees would have to total 90 degrees. And then you could solve that little equation by combining the like terms and dividing by 9. And then you would get that x is therefore equal to 10 degrees. And so if the first angle was 3x, that would be 30 degrees when we multiply 10 by 3. And if the second angle was 6x, that would be 60 degrees when we multiplied by 6. And they could give you a slightly more complicated version of this and ask you to do a little bit more algebra. But here they're trying to sort of refresh some of your algebra from before that we'll need to use during the course of the class, but also use these new images and these new vocabulary words and these new ideas so that you get practice with those at the same time. Questions, comments, discussions about that at all?
The remembering the terminology is important
I think
because
that's a comment.
I'm from South Korea, so like every terminology is really kind of new to me.
Mhm.
So do I have is it important to like remembering like all of the terminology like complement or the kind of stuff?
Well, I think you might find when they first introduce these words to you, you might find some problems that ask you about those words directly. So you might just need to remember them or be able to look them up on your notes or in the book while you're doing those kind of problems at the time. As we move away, then we're not going to expect that the key part of the problem is memorizing the definition of a word, but they're going to use this language to talk about the problems that we're doing in trigonometry. And if half of the words they're saying, you don't know what that means, you're not even be able to understand the question of the sentence. So the reason we begin a class with terminology is because we want to be able to use this language so that we can talk about it in the future. Does that make sense?
Okay.
Yeah, like imagine you're along a beach and you have a boat that goes off in a certain direction and you say, okay, it headed off in the direction and the acute angle the boat makes with the shore is 16 degrees. Well, they're hoping that that word helps you know which angle they're talking about. Like if you're visualizing that and drawing that, oh, you mean that one that's less than 90 degrees over there, that's this one right here, because they've used that word to help you say that. Or they might say, find the acute angle the boat forms with the shore. Well, you'd have to know what they're talking about. Does that make sense?
Yeah, okay, thank you.
Yeah, it's really about the functionality.
Professor, at the bottom, it said like determine the measures of each angle by substituting 10 for x. I'm kind of confused on that because the answer is x equals 10.
No, it's not. So I wrote the answer over here, 30 and 60, because they asked us to find the measure of each marked angle, and that was here and here.
Oh, never mind. I got it. It was substitute. Okay, never mind. I got it.
Substitution happened is that the way I got the 30 was I plugged the 10 in for x and multiplied it by 3 to get the 30, and that's the substitution they're talking
Yeah, no, I got it. Sorry. That was a stupid
about.
question.
No problem. All right, so we were able to get through 10 out of these 24 slides with our fun time today, which is now coming to a close.